Hello everyone, we team Navyuva and we are excited to present our project idea Intern Mitra under the theme Smart Education for the Smart India Hackathon 2025. Our problem statement is to design an AI-based internship recommendation engine for the PM internship scheme. Now look at the background. The PM internship scheme receives thousands of applications from students across India, including rural, tribal and remote areas. Many of these students are first generation learners with limited digital exposure. With hundreds of the students listed, they often struggle to find the right match, leading to mismatches, rejections, and missed opportunities. To solve this problem, we propose Intern Mitra, a simple, lightweight, AI-driven recommendation system based on candidate details like education, skills, sector interest, and locations. Intern Mitra suggests top 3 to 5 most relevant internships instead of overwhelming candidates with a long list. What is our innovation and uniqueness? When it comes to the innovation and uniqueness, we are providing a simple and intuitive way, which is same as the PM internship portal, so they can access and can be interact with the recommendations that were given by our model. We are proposing a lightweight recommendation engine so that it can embed it anywhere. Even though there are lots of applications coming at the same time, our model can be able to access them and process them and giving the best recommendation based on them. We are proposing, as per the recommendations, we are showing the success chance visibility. It is the probability match that how much percentage that you are suited for this particular internship that was recommended by our model, and it was easy to integrate as it was a lightweight recommendation model. It can be embedded it anywhere. As we are proposing a voice based help, it can enable for the it is proposed for the 10th and 12th class students, as they are not aware of these kinds of recommendations and things, so they can interact with our UI through the voice live application stacker. This is one of the future we are proposing for that recommended internship. How many of the applicants have been applied for that particular internship? For the final feature, we are providing fair distribution feature. This is what actual means is for lots of the applications that are recommended by the same internship at some time. Some person may think, how can I supposed to give, so as there are so many applications, so we are providing a button so that he can go to next 5 internship recommendations. This can be given for only if the probability chances for the getting the internship, that means if more than number of the applications are given for the particular internship, we are providing a button so that it can our model can be provide the next top 5 internships. When it comes to our problem tackling, we tackled this problem as a 2 pages. One is data integration and another one is model building. When it comes to data integration, as we are building a model, it is hard to find the dataset that is well suited for our solution, so we use some web scraping techniques. We get our dataset from the internet, from the PM internship scheme. One of our teammate has worked on it and created a dataset. He will explain how can he build the dataset using these techniques.
Coming to data integration, we identified this is one of our biggest challenges. By analyzing the PM internship scheme, we discovered that internship data is scattered across multiple state portals and central AICTE portal. We implemented a systematic state-by-state data extraction approach. For each of 36 states, we developed a custom web scraping modules by Python libraries like Beautiful Soup and Selenium. The core of our approach was advanced deep scraping, a technique that extracts data from nested pages, handles JavaScript rendering content, and adapts to different portal architecture. This was crucial because each state has its unique structure and data format. We developed a scraping algorithm across all states portals, simultaneously extracting key information like skill specification, education requirement, sector classification, and location preferences. After collecting the data from all sources, we implemented a comprehensive data normalization which involves removing duplicates, handling missing values, and ensuring consistency across the different state portals. The final result was combining all the datasets, unified training foundations for our machine learning model. This comprehensive approach ensures our recommendation engine has complete access to the entire PM internship ecosystem. Now let me hand over to Saurabh for model architecture.
Since our recommendation engine has to integrate seamlessly with the PM internship portal, our technical approach was built with two goals in mind: lightweight processing and high compatibility. Here is how we achieved that. First, let's look at the workflow. The process starts with the candidate input, where students provide their education, skills, interests, and location. And parallelly, we collect internship data such as roles and requirements. Both sets of data are then pre-processed to remove noise and bring them into a standard format. Next, NLP processing extracts semantic meaning from text. Using TF-IDF feature extraction, we convert descriptions into numerical vectors. Then, we apply cosine similarity to calculate how closely a student's profile matches an internship. And with logistic regression, we rank and score the internships. And then the system presents the top recommendations. Now, the technical approach. For the front end, we use React with Tailwind CSS to build a responsive interface. The backend is powered by Python with Flask for deployment. We handle data using NumPy and Pandas, while scikit-learn implements our AI models like TF-IDF, cosine similarity, and logistic regression. We also plan to include accessibility features like React I18 Next and Voice Assist. We selected this tech stack because it provides the right balance between lightweight performance and seamless integration. Since the recommendation engine should not add extra complexity, the chosen technologies ensure faster pre-processing and easy scalability and small and smooth deployment. Moreover, we also analyzed the PM internship portal existing tech stack to make sure our solution integrates effectively without any compatibility issues. We aligned our choice accordingly. This makes our tech stack not just efficient and lightweight, but also the most suitable for direct integration with the PM internship portal. And here is the prototype. Students register by entering their skills such as education, sector preferences, and their high performing skills and location. Based on this, our engine displays personalized internship opportunities with details like stipend, role, duration, and an option to apply directly. The design is fully responsive, ensuring a smooth experience across mobile and other devices. And that covers how we design the engine from workflow to tech stack to prototype that students will actually use. The next big question is, can the solution really work in practice? For that, my teammate will dive into feasibility and viability.
Let's discuss about feasibility. The solution is technically simple to implement, fast at runtime, and requires minimal software dependencies. Operationally, it needs no model retraining, monitoring, or ML expertise. Designed for mobile-first low-literacy users, it offers highly explainable recommendations. It works effectively with only basic readily available candidate and internship profile data. Integration is seamless, allowing direct incorporation into existing portal backends. Let's see about viability. The solution is highly viable. It builds community trust through transparent, explainable recommendations and scales efficiently to serve millions of students nationwide. It runs fast inference on low-cost servers too, minimizing infrastructure expenses. With no need for complex models or ongoing retraining, long-term maintenance costs remain low. Now, risks and strategies. On the left, challenges like poor data, bias, scalability, weak skill matching, lack of transparency, and privacy concerns. On the right, solutions including data cleaning, bias audits, scalable ML with caching, skill ontology plus semantic matching, explainable AI, and encryption or access control. The visual metaphor shows we can offset each risk with a targeted technical or ethical strategy. Having discussed the feasibility and viability, I will now hand it over to my teammate to present the impacts and benefits.
To explain impact and benefits by addition of AI recommendation engine into the prime internship website scheme. It is mostly impacted and benefited for the students because the recommendation engine recommends top 5 internships to the student based upon his skill set and profile. And we even had a small and smart feature which tells that the percentage of getting a student into the internship that he had applied and what is the chance of winning the internship among the competition. And this recommendation engine would even save his time by not searching all the internships that are provided by the website, but he could only filter among the internships that are recommended by our system. Secondly, this recommendation engine would benefit for the providers because the provider's mission is to provide youth of 1 crore with the internship opportunities. But they have come with a problem that internships are being offered and the students are even applying for it, but they couldn't. The students are not joining because they were applying for the internships that are out of their location preferences. But this recommendation is the one and only solution for that problem because this recommendation engine would provide recommended internships to that candidates so that they would easily apply for it that are in their location preferences. So there will be no more dropouts. Just apply, accept, and join. There will be seamless placements because the correct student would get an appropriate internships, and it would even benefit for the companies because the companies with a good and efficient skill set will acquire a good skilled candidate. A candidate would get a really skilled and an experienced company, and you wouldn't even have a experienced work life. And it would be time savior for the companies because hiring and screening is even done. Half of the screening is even done by the internship recommendation side, and they could even take for a small personality test, and they could even hire them. So these are the small impact and benefits that are offered by this recommendation engine. And we even predicted that if this recommendation engine have been implemented, then there will be nearly 30% more offers applied to the candidates, and there will be nearly 14% increase in the acceptance of the joinees into the internships companies. Thank you.